Hello everyone, first of all thanks for being here in my YouTube channel. Let's see the problem. A non-inductive resistor of 10 ohm is in series with capacitor of 100 microfarad across 250 volt 50 hertz AC supply. So we'll draw the diagram now for this question. There is a resistance capacitance are connected in series across 250 volts 50 hertz supply, right? So the resistance value is 10 ohm and capacitance is 100 microfarad, right? So what we need to calculate, determine the current taken by the capacitor. So I we need to calculate, and then power factor of the circuit. Power factor we need to calculate. So what is the formula for I? I is equal to V by Z, right? So this is Z, okay? This is Z impedance. So Z we don't know. We need to calculate Z now. Z is equal to what? R minus JXC. Minus will be there for RC circuit. Plus will be there for RL circuit. 1 by J omega C will get. So 1 by J will get minus J. Okay. So Z is equal to, I'll substitute over here, 10 minus J XC. How much? XC is not a 100 microfarad. C is given. We need to calculate XC now. So XC is equal to 1 by 2 pi FC, right? 1 by 2 pi F into capacitance. How much they have given? 100 microfarad, that is into 10 raised to minus 6. Finally, you will get answer as 31.83 ohm. Okay. Now we can substitute 31.83. If you have taken 100 over here, definitely the whole problem will be wrong. Okay. Z we got this value. If you want to calculate in terms of polar form, so like this we can calculate 10 square plus 31.83 square. Phi is equal to tan inverse of XC by R, 31.83 divided by 10. This value will get 33.36 angle. This phase angle phi is minus 72.55 degree. Okay. So no need of this calculation. Directly you can calculate I is equal to V by Z, that is 250 divided by 10 minus J 31.83. Just to use calculator. So you'll get 2.24 plus J 7.14 will get it. So just to use calculator, okay. This is plus J0 will be there. Okay. So after converting this one is in polar form, so we'll get 7.49 angle 72.55. Okay, we'll get it. So how to calculate this one is current. This is a current. I is equal to what? 7.49. Just to calculate like this, 250 divided by 33.86, you will get 7.49. Okay. Next, we need to calculate power factor. Power factor to cos phi. So cos phi is equal to what? This phi you have to substitute. Cos of 72.55. What you will get? 0.3 as a power factor. Power factor always will get less than 1. Okay. This is the answer. Okay. Once again, we'll cross check the answer. So we got 31.83 XC and then Z is equal to this value and I is equal to 7.49 angle 72.5. Directly you can calculate by using calculator. Okay. Just you put it in complex form and then you'll get answer. And 5 we got 72.5. So cos of 72.5 0.3. This is the answer. So next problem, an impedance coil in parallel with 100 microfarad capacitor is connected across 200 volts 50 hertz supply. So impedance coil, definitely inductance will be present, right? Coil they mentioned R plus JXL must be there. So connected parallel with 100 microfarad capacitor, right? So connected across 200 volts 50 hertz supply, right? 50 hertz. This one I'll take Z coil, okay? Z coil 1. So coil takes in current of 4 amps. Here 4 amps. Okay. And then power loss in the coil is 600 watts. Okay. Calculate resistance. R we need to calculate. And the inductance we need to calculate. So L we need to calculate. And the power factor we need to calculate for entire circuit. Okay. Now see the question properly. Power loss is given, right? Power is equal to I square R. So power loss will be occurring only resistance. Power is dissipated only resistance part. Okay. So R is equal to P by I square, right? So definitely 600 by 4 square, you will get 37.5 ohm. Next, how to calculate the L value? I mean XL value. Z coil is equal to root of R square plus XL square, right? So the formula Z is equal to uh, R plus J XL. So I converted into this one modulus. So Z coil is equal to R square plus XL square. So we need to calculate XL square because R we already knows. Z coil we don't know, right? So Z coil how to calculate? Z is equal to V by I. That is Z coil. So what is same, right? What is same for both the branches, because this is a parallel circuit. So Z coil is equal to V is 200. I is equal to V by Z. Okay. So 200 divided by I is 4. Definitely we get 50 ohm. Okay. Now I'll substitute over here. So we want XL. Z coil square is equal to, I'll be taking root outside, so R square plus XL square. See here, Z square I have taken here. So we want XL square is equal to Z coil square minus R square, right? So XL is equal to root of Z coil square minus R square. So XL is equal to 50 square minus 37.5 square. XL we got 33.07 ohm. So now we need to calculate L. So XL is equal to 2 pi FL. Formula will be there. L is equal to XL divided by 2 pi F. So XL is how much? 33.07 divided by 2 pi into 50. Finally, we got L is equal to how much? 0.105 Henry. Just to put bracket over here. Okay. Now we need to calculate power factor, right? Power factor how to calculate, because there is no, I mean, like phase angle. We need to find out Z equivalent. There will get power, I mean, phase angle, right? So Z equivalent is equal to Z1 into Z2 divided by Z1 plus Z2. So Z equivalent is equal to Z1 is Z coil, right? This is Z1 will take. This one will take Z2. Z1 is 37.5 R plus JXL is XL is how much? XL is 33 point J 33.07, right? What about Z2? Z2 is equal to minus J XC, how much? XC is XC we don't know. We need to calculate XC now. XC is equal to what? 1 by 2 pi FC. Just you substitute the value 1 by 2 pi into 50 into 100 micro. So we will get the answer as XC is 31.83 ohm. So XC we got 31.83. Okay. So minus J 31.83. So Z1 is this one, Z2 is this one. So just I'll substitute over here. 37.5 plus J 33.07 into this Z2 minus J 31.83 divided by Z1 plus Z2. 37.5 plus J 33.07 plus minus J 31.83. Okay. So finally we'll get Z equivalent as 27 minus J 32.72. Okay. We got, if you convert into polar form, we'll get Z equivalent is equal to 42.42 angle, use calculator, okay, minus 50.5 degree. So finally cos of 50.5 degree will get power factor. Cos of 50.5 degree will get 0.6365. Okay, directly we can solve the problem. Once again cross check the problem. There is a Z coil 50 ohm we got, and power is equal to I square. R we calculated 37.5, right? And then XL is equal to, we calculated by substituting these values, 33.07 we got. L is equal to 0.105 we got, right? X is equal to 31.83 we got. So Z1 we have taken R plus JXL, right? Z2 is equal to minus JXC, right? So Z equivalent we calculate Z1 into Z2 divided by Z1 plus Z2. We got 27 minus J 32.72. We got 50.5. Cos of 50.5 degree, definitely you get 0.6365. So power factor always less than 1, you will get it. And next problem, a circuit having a resistance of 20 ohm and inductance of 0.07 Henry is connected in parallel with the series combination of 50 ohm resistance and 60 microfarad capacitance. Calculate the total current when the parallel combination is connected across 230 volts 50 hertz. We'll draw a diagram now for this question. There is a resistance and inductance. So connected parallel with series combination of resistance and capacitance. So this one is 20 ohm they have given, and then 0.07 Henry, 50 ohm and 60 microfarad, right? So the supply voltage for this parallel combination is 230 volts, 50 hertz, 50 hertz. What we need to calculate? Current we need to calculate. I is equal to V by Z equivalent, right? So first we need to calculate Z equivalent. So Z equivalent is equal to what? This one I'll take, this part I'll take Z1, okay? This one I'll take Z2, right? So Z equivalent is equal to Z1 into Z2 divided by Z1 plus Z2, right? So what is Z1? Z1 is equal to R plus J XL, right? So inductive circuit. XL they have not given. L is given, okay? So XL we need to calculate. So XL is equal to 2 pi FL. So we'll get the value as 2 pi into 50 into 0.07, we'll get 22 ohm. Okay, this is XL. So Z1 is equal to 20 ohm plus J 22 ohm. Okay, this is Z1. What about Z2? Z2 is equal to R minus JXC, right? So R they have given 50 ohm minus J. XC they have not given. XC we need to calculate. XC is equal to 1 by 2 pi FC. So 1 by 2 pi FC is 50 into 60 into 10 raised to minus 6. So 60 microfarad is given. So finally we got XC is equal to 53 ohm. So here 53 ohm. I'll just substitute over here. So Z1 is 20 plus J22 into this one is 50 minus J53 divided by 20 plus J22 plus 50 minus J53, right? So finally we got Z equivalent is after calculating this one, just to use calculator, 25.7 plus J11.9 we got. Okay. Now you calculate I is equal to 230 divided by 25.7 J11.9. Finally we got 7.4 minus J3.4. So if you convert into power form, I is equal to 8.13 angle minus 24.9. Use calculator, okay? Use calculator for this calculation. Okay. Once again, we'll cross check the answer. There is a x is equal to 2 pi fl, and then x is equal to 53. We got z1 is this value, z2 is this value, and z1 into z2 by z1 plus z2. So we got this one, and I is equal to v by z. This is the answer.